All right. We're going to do a quick morning stream here. Let's see if we can figure something out. Okay. Before I called this by hand, but that of course is not correct. It's without the f of t. All right, now what I'm going to do is make a function circconv 1 without the f of t, ak, great. This function is not going to stay around. This is just for testing. I believe this is it. Local test. Other people would probably make this a script, but I don't do that. I just make everything a function. Because I don't like when things hang around. I understand functions. All right. Let's see if this runs. Seems to run. Great. Now, why did I do this? My contention, remember, was that circular convolution with k flipped is its own adjoint. So here I'm thinking of this as like function out equals f of in. And f is equal to circconv1 without f of t of a and in. Gotta do the circular convolution stuff. A and K are real, they're random, right? Does this run? I haven't changed anything. Sure enough, it runs. Okay, now I'm going to check the adjoint of this. I don't remember how check adjoint works. I could either look it up or just come over here. Nope, not there. Oh, okay, now I'm going to look it up. Check adjoint. AFN. What on earth is blur? That must be the function in that other library. Okay, so this is going to be AF adjoint. The at symbol, of course, gives you the function handle. What do you guys think? Think it'll work? Totally wrong. Okay. Now we've got some simple stuff to work with. What's the size of K? 20. We're going to make these things smaller. That crashed. For the same reason as before. There you go. I am going to look at this matrix. Circular convolution matrix is going to be of size max mn by max mn. It's going to be square. To make the matrix for a linear transformation, you apply the linear transformation to each element of the standard basis, and then store the results as the columns of the matrix. So C com mat, the first column is going to be F. And so here's going to be the standard basis. E1 I'm going to say is zeros max mn1, and then E1 1 is going to equal 1. Right? It's the first element of the standard basis. That should be the matrix. Okay. I never get rid of these these things, but for right now, I'm going to minimize it. I was hoping that would let me see all the columns, but it doesn't, so I'm going to reduce it by 1. MATLAB's got a bug in it now. I actually contacted MATLAB about it. Okay. You're supposed to be able to set the font size in this window using their, preferences panel, but that's buggy. MATLAB cannot currently get their font sizes correctly. All right. Let's make this real for right now. Make it easier to see. Okay. It is indeed circulant. Question. Does the adjoint test work with real values? The answer is no. Great. Let's look at its transpose. Why am I doing this? Let's make K something we can see easily. That doesn't make sense. Of course it does. There we go, changing the font again for no reason that I wanted it to. Okay, it's not K that we need to make simple, but A. What happened to the rest of my function? There. So here, the kernel is 1, 2, 3, 4, 5, 6. And here, sure enough, the kernel is that flipped. What happens? So the transpose of the convolution matrix, the circular convolution matrix, is this. And that appears to me to be circular convolution with the kernel flipped about the origin. The origin is in the fourth location. Is that right? Wait. There are 6. Yeah. The fourth location is the origin, right? Yes, the origin is the fourth location. What happens if I make the matrix for the adjoint? Let's find out. I'm losing this, so conjugate transposed. Huh. Well, there's a problem. There's a problem. This needs to be adjoint. Okay, that was a silly problem. You're joking. Oh. What? What? You see what happened? It's like rotated. They're constant along the wrong diagonals. Why? Because I'm flipping and shifting the wrong thing. That's why. I don't want to be flipping K or in. I want to be flipping A. Flip. Okay. Why did I flip K here? Because that's what convolution is. Okay. I haven't padded here. That's okay because A is the larger one, but this, of course, would break, and I don't care. Okay. Look at that. Look at that. The adjoint check is now working, and the error is 0. Let's see if this works with random stuff. Sure. Let's see if it works with complex stuff. Ooh. Okay. Numerical precision error when the inputs are real Not so much when the inputs are random. I mean, are complex. Then we're getting significant stuff. Is that to be expected? Of course not. I mean, is that to be expected? Of course it is, because we need to put a conjugate right there, don't we? And now we're down to numerical precision as the error. Great. I suspect we're about to fix this. Open test work lib. If I search, it goes way to the end. Like, I gotta make it very small so that if I hit Control F or Command F, then I can see what's in the find. Otherwise, if I hit Command, okay, so that changed the font again. If I hit Command F, oh, now it works. Ay, MATLAB. I got to meet Nicholas Trefethen, who's a very accomplished researcher, and he has given up on this window entirely. He just doesn't use it at all. And it's tempting, because then I could just use Vim. But I use the debugger all the time. 212. Oh, here we go. Look at that. Okay. Still fails. Okay, we've got it working over here. Without the FFT. And this seems to suggest, oh no. That operating without the FFT and operating with the FFT give you the same results. So what to do? Okay, I've replaced that. If I replace the operation in the function f to be from the circular convolution without the FFT to the circular convolution with the FFT, oh, then nothing works. Okay, why? The nested function name f may not be reused in the same scope. Did I do that? I guess I did. Okay, that's still giving me numerical precision of error, so everything's working just fine. Let's do the same thing for the adjoint. If I do this, still works just fine. But if I do this, I'll bet you it won't. Okay, so the problem is in this little code right here. These, this tiny little code. So it's given me the problem. A has 6 elements in it. It's even. There's a problem. The test was wrong to determine when to do the circular shift. I think that's going to be it. No. Wow. Okay. And out is 6. So n out mod 2 is even. Oh, when we're even, we want to do the circular shift. There you go. Circ conv 1 is working and complete. Let's check it in. Wow. It's not here. It's not here because, of course, circ conv 1 was only in that little directory. No. Documents, MATLAB, dworklib. Over here we got Dropbox schools, CU Anschutz, projects, and what on earth did I call this thing? SPIRiT. Adding circ conv 1 to the repository. This is some minor code. Minor change to a code that was part of another project. Okay. This test, I keep forgetting that. That test passes. If we do this, it still passes. I've run it many times to make sure that it's just not appearing to pass on the one, for the one realization of the random numbers. I want to check that it passes a lot, and it does. Where does that leave us, right? So now we can remove the local tests. Well, there's a lot to fix here. Okay. Okay, I'm just doing odd stuff. Adjoint test fails. Ah, did it again. All right, here we are. The size, oh. Still failing. Let's open circle column 1. What is the difference between these two codes? Huh, okay. Dimension. Does dimension have to be a scalar? Based on that test we did the other day, I'll bet you it does. It does. At least it says it does. I'll bet you that's right. Okay. If mod size had a, in the first dimension, ooh, that looks like an issue, doesn't it? Okay. Pad A is equal to circ shift pad A, the first dimension by 1, if mod size pad A, the second dimension is that right? The dimension is the last variable. Okay, so I did that wrong. Think that'll work? Nope. This is kind of a neat effect. See how it comes back. It's pretty. Okay. Still failing. All of these things are odd. Look at that. We're not using X. Oh boy. Okay, when you pass an input to the argument, when you pass an input to a function, you really want that input to be used correctly. That, it turns out, is key to making things work. And look at that. Now we've got circular convolution 2 working. What if I make one of these things even? No. Not only is it not working, it's crashing. Circ shift for inputs of arguments type double undefined function circ shift. That can't be right. I put a capital S in for circ shift. Passes. How does this know? Oh, because it's a matrix. Okay. You don't need that. And just to be sure, we'll go through all combinations. Still passes. Still passes. Circ conv 2 is done. You can delete circ conv 1 without FFT. Test work lib has, the differences are that it's added the tests for circ conv 1 and its adjoint and circ conv 2. Adding circ conv 2 and tests to the repository. All right. I have a decision to make now. This function, circconv, is meant to do circular convolution on all dimensions of arbitrary multidimensional arrays. Looks like I tried to be clever. So I can either fix that, go on to other work, or just end streaming and do other work, or just go back to SPIRiT regularization. We're not going to do more SPIRiT regularization today. That's going to be for another day. This is one of those moments where I know if I don't do it right now, it's going to be so much harder next time. The circ conv test passes. This looks like I'm comparing just one. Let's see if we can fix this quickly. Oh no, I'm comparing circ-conv to MATLAB's convolution. Okay. I started this in 2021 and I still haven't gotten to it. This looks interesting. So this test fails, right? Yes. This test currently fails. Fine. Here's the issue. Here's at least an issue. This should be A, shouldn't it? (64 by 128). I'll bet you this gives me an array of ones. I don't know why I needed that instead of just doing this. I'll bet you because it requires circ shift A to pass in an argument of. That's interesting. I didn't make circ shift, right? No. So you could just give it an array, an amount to shift in each dimension. Okay. One. Great. Because it's even. Oh. Whoa. IF50 shift, doc, IF2 shift. Does that do it in each dimension? If y is a multi, swaps half spaces of y along each dimension. Okay, it does it to the whole thing. Good function, MATLAB. Good function. IF50 shift FFT. Oh, why am I doing something different based on transpose? What is different based on transpose? Doesn't appear to be anything, does it? All right, so that's not necessary. Does it work? No. Ooh, but not too far off. That's going to be hard. Okay. You want to flip after padding. That didn't fix it. Can I arrange this? Okay, these lines now sort of line up. I want to call this pad A, pad K. Oh, pad A, pad A, pad A, pad A. Does that work? No. Why not? I'm using my phone to check if my Twitch stream is still working. Something just happened. Huh. Oh, there we go. We seem to be back. Okay. Why doesn't this work? Insert column 1. I want to avoid doing a string comparison if I don't have to. Okay, so there's this problem where I wasn't conjugating. Guess I'll do the orders the same way just to make the codes uniform. Man, those codes look pretty similar, don't they? Blah. Of course, I should be able to do this in 3 dimensions. It doesn't crash. That's kind of nice. call this A. I clearly was thinking this is an image blurring operation. Oh, no. It still matches. Huh. Okay, that was just a fluke. Luckily, circular convolution is associative, so it doesn't matter which are the order that you put in the arguments. It's matching. Matches the results. Yeah, it matches. It's just the adjoint that's failing. What? That fails. Okay. Oh, blur check. Right, whatever. Oh, because it's circumv 1. Okay, thank goodness. Incompatible sizes. What's happening? Okay, this should be A. Now we're back to where we were. I mean, this is just usage. Same here, just usage. AK op. AK op. that passes circ conv 1. I don't know what any of this is. I don't see any meaningful difference here. I may not understand what IFFT shift and FFT shift do in n dimensions. This test fails. Okay. What on earth is that? Open circ conv new. This was me trying to fix this long ago. This doesn't look materially different. Who knows what this was? It's not part of the repository. It's gone. What? Oh, that's just that, not the adjoint check. The adjoint check fails. I could do the thing again. Four, I equal 1, 2. Let's make this smaller. 2 by 3. Okay. See, in 2 dimensions, it's going to be tougher, but let's see what happens. E1 equals zeros, 5, 1. E1 of 1 equals 1. The matrix for A is zeros, 5. Matrix A F applied to K. No, circ shift E1 I minus 1. Display map A. What's the problem? Not enough input arguments. Up. arrays having compatible sizes. Arrays having compatible sizes. Oh, right. Okay. Size A. Because the left side is 5 by 1 and the right side is 6 by 1. Why is it 6? Because 2 times 3 is 6. Equals reshape 1 to 6, 2, 3. 4, 3, 4, 3, 4, 3, 4, 3, 4, 3, 5, 6, 5, 6, 5, 6, 6, 6. I don't know if that's right or not. I have no way of knowing. The only thing I know is that H is short for Hermitian adjoint. Those are the same? That's a problem. Oh, it's flip. Flip is only flipping in one dimension. Reverses the elements in each column. If A is an MD array, then flip. Ay, man. Okay. There's no flip in all dimensions? MATLAB flip all dimensions. Flip dim? My goodness. Adjoint test passes. But that's just because I'm passing in a two-dimensional array. If I were passing in a three-dimensional array, it wouldn't work, and I can't do this, right? Function out equals flip all dimensions in, end. Source code copywritten in 2025. An array of any number of dimensions. An array of size equal to in where all dimensions have been flipped. Is there a way to, how do I find the NDIMs? Open NDIMs. Or I equal 1 to NDIMs in which is equal to 0 size in. Well, see, it makes a copy. MATLAB always passes by value. The most efficient thing to do would be to just output in. X equals flip xi. Does that work? No? Passes. Okay. So flip was doing something different than what I thought it was doing. Flip about index. I don't know what that is. We'll worry about that later. What did I do here? I'll undo that. Those are just renames and stuff. Fine, whatever. Oh. No. Sort conv adjoint. Forgot some stuff, didn't I? Still passes. 4-dimensional array. Everything's working. Circ-conv now works. Circ-conv and its adjoint now works. which means the next time we can go back to working on SPIRiT regularization. And we've got a fully functional circular convolution that has its adjoint operation. Good stuff. See you next time.